Okay, Assalamualaikum warahmatullahi wabarakatuh. We continue with draft. Okay, draft is provide angle like this to the parts or tapers on product features, okay, such as walls, ribs, and bosses that lie parallel to the direction of release from mold. Okay, kalau kita nak releasekan produk ni ke atas, so kita kena design draft parallel to the parallel to the direction of steel preparation. Okay, this is the incorrect design of draft, so this is the correct one. Okay, we design the angles here, and the reason for draft is for easily remove from the mold. Okay, we want to eject the part from the mold. We want to release the part from the mold so that the part can easily ejected. Okay, this one is incorrect design, and this is the correct design for bosses. And okay, sorry, this is design for rib. Okay, and this is design for bosses. So bosses rib should taper thinner, okay, as they extend into the mold. Okay, so surface formed by slides may not need draft if the steel separate from the surface before ejection. Okay, okay, draft ni penting untuk kita kurangkan kerosakan pada part during ejection. Okay, kalau kita tak nak letak draft, maybe molders ataupun engineer kena letak mold release agent or special mold surface coating ataupun treatment lain lah. Ultimately leading to longer cycle time and higher part cost. Okay, hull and core. Core are the protruding part of the mold that form the inside surface of features such as hole, pockets, and recess. So core ni adalah yang ni, hole yang ini. So what is the function for core and hole? Okay, core ni dia senang untuk kita remove plastik. Okay, core ni untuk kita removekan plastik, and dia juga fungsi dia to maintain a uniform wall thickness. Okay, whenever possible, design parts so that the core can separate from the part in the mold opening direction. So it is a design in the mold. Okay, designer must design the core so that can easily separate from the part in the mold opening direction. Okay, kalau part ni susah nak, part yang kita design core ni, plastik dalam ni susah nak keluar, so kita boleh letak slides or hydraulic moving core that can increase the cost of mold construction and maintenance. The depth to diameter ratio for blind hole should not exceed 3 to 1, which is 3 is depth, diameter is 1, or 5 to 1 are feasible if filling progress symmetrical. And if the core is supported on both ends like this, the guideline for length to the diameter ratio, maybe typically we use 6:1 or up to 10:1 if support on both end. Okay, core ni dia support dekat both end. So the level of support on the core end determine the maximum suggested ratio. Okay, filling if feasible if filling progress symmetrical and 6:1 but up to 10:1 if support on both ends. Sebenarnya dia refer kepada gambar yang ni bukan yang ini. So gambar yang ni dia cerita pasal mismatch. Okay, mismatch can reduce the size of the opening in hole formed by mating core. So design permitting make one core slightly larger. Yang ni dia design core yang kat bawah ni lagi besar daripada yang core kat atas. Apa tujuan dia? Dia takut mismatch of the plastic product. Okay, so the required hole diameter can be maintained. So tight tolerant hole that cannot be stepped may require interlocking features on the core to correct for minor misalignment lah. So this feature add to more construction and maintenance costs. This is the example of core. This is lifter. This one is ejector pin. And this is the ejector plate. And this one is more cavity. Okay, we proceed with undercut. Okay, some design feature because of their orientation place portion of the mold in the way of the ejecting plastic part. Okay, core undercuts. This element can be difficult to redesign. Sometimes the part can flex enough to strip from the mold during injection. Okay, but depending upon the undercut's depth and shape and the resin flexibility. So the undercut is indentation or projection on the wall of plastic part which interfere with simple ejection, increase the cost considerably because special split and retracting mechanism required. Okay, this is undercut. Because undercut cannot strip from the mold, it needs an additional mechanism. Okay. This is the additional mechanism by includes like split core, collapsible core, split cavities, core pull, cams, cam pins, lifter or spring. So disadvantages of undercut, it can add to more cost and complexity and maintenance as well as hidden costs. Video about undercut. This example of injected molded part. Okay, this cavity and this is the core. When injecting this resin into the core, let's see what's going on inside. So this is actually the undercut. So it is hard to remove from the mold. So undercut cannot remove from the mold, it needing an additional mechanism. So this is the one of the mechanism we use. The type of mechanism includes like split core, collapsible core, split cavities, core pulse, cam pin, lifter or spring. So undercut has disadvantages. It is add to more cost and complexity and maintenance as well as add hidden costs in the form of increasing production scrap, quality problems, flash removal and increase more downtime. Okay, thread. This is example of thread and this is example of thread. Okay, this is internal thread and this is an external thread. What is the purpose of thread? Okay, for the part of plastic that don't need a screw. So thread design requiring unscrewing devices, and thread ni most will increase the cost to the mold. Okay, these three figure it show the common thread profile used in plastic. So this is example of thread profile for metal screws. Often they have a sharp edge and they have a corners that can reduce the part mechanical performance and will create molding problem in plastic design. So by rounding the thread crest and roots, will lessen this effect. So we should consider these 4 points when specifying the molded in threads. Okay, this is example of thread. Internal thread visible at the far end, and this is the external thread at the front. Okay, for this image, stop thread short of the end to avoid making thin featured threads that can easily cross thread. So dia kalau design ni yang design yang tak betul. So kalau design sebetulnya dia buat separuh je kat sini. Sama juga. Bukan full design, dia punya design dia separuh sahaja sampai sini yang dekat hujung tu. Lettering. The molding process adapt easily for molding in logos, labels, warning diagrams, and instructions, saving the expense of stick-on or painted label and enhancing recyclability. Okay. So deep, sharp lettering is prone to cosmetic problems such as shown in the above. Okay, deep, sharp lettering is prone to cosmetic problems such as streaks and tear drop, particularly when near the gate. So, deep, sharp lettering can cause tear drop defect as shown in this photo. So the bottom shows the improvement with rounded, okay, rounded and shallow lettering. So we can address these cosmetic issues by consider the following, which are limit the depth or height of lettering into or out of the part surface to approximately 0.01 inch and angle around the side walls of the letters. Tolerance. Many variables contribute to the dimensional stability and achievable tolerance in molded parts, including processing variability, mold construction, material characteristic, and part geometry. In order to improve ability to maintain specified tolerance in production, designers should use low shrinkage material in part with tight tolerance. Avoid tight tolerance in dimension affected by the alignment of the mold, half or moving mold components such as slides. Design parts and assemblies to avoid tight tolerance in area prone to warpage or distortion. Adjust the mold to produce a dimension in the middle of tolerance range at optimum processing condition for the material. So to avoid unnecessary molding costs, specify tight tolerance only when needed. Generally, the size and variability of other part features will determine the actual tolerance required for any one component or feature within an assembly. Okay, tolerance mean it is an terms ataupun approach yang designer guna to understand how imperfection in parts as they are manufactured to meet the customer requirement.